Alright, we're dealing with scientific notation. Our unit EQ is still what are ways to engage and express knowledge of exponents and linear equations. Well, before we get started, I do have a little video that I kind of put together, and it's just a way to kind of entertain you before we get started.
What is this I hear about something called scientific notation?
It is the process of taking a gigantic number and making it smaller.
Smaller? How do you make 42 million smaller?
Move the decimal to make it 4.2 times 10 to the 7th power, and there you have it. Or, you can take 0.0004 and make it 4 times 10 to the negative 4th power.
So being able to take a number and make it smaller, whether it be 46 million or 3.2 trillion, or it could be something in the decimal of you have 0.0000004, and actually taking that and making it, writing it much smaller. Well, let's actually get started on doing this. If I look at this, how do I translate scientific notation to standard form and then back to scientific notation? Well, as we get started here, as we look, we see, first of all, this is a positive exponent. Well, that's going to tell me how many spaces I need to move my decimal. And when it's a positive, for example, here I have 3.12. I'm going to simply move my decimal 9 spots to the right. And when I see a positive, that means that's going to be a positive, a kind of big number and to the positive. Here, when I say, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means I need to add zeros to all these spots. And in this case, I'm going to have, maybe, and there we go. And in the grand scheme of things, when you're dealing with numbers, honestly, I would much rather deal with something that looks like this than to have to worry about all those zeros. But transforming this from here, this is the scientific notation, this is the standard form. I always look at it, the standard form's the big way of doing it, and the scientific notation is the smaller way. Alright, let's try just a couple, and then we'll move on to the next. If I have 4.17 times 10 to the third power, well, in this case, I have 4.17. Right, that tells me positive exponent. That tells me how many spaces I need to move that decimal. So I go 1, 2, and I have one more spot, 3. So I have 4,170 would be the standard form. Alright, on the next one, what I want you to do, I want you to try this one before you ever watch the video or listen to me any further. Go ahead and try this one on your own. You got 6.2 times 10 to the 7th and see what you come up with. So if I have 6.2, that means I need to move that decimal 7 spots. Well, here's a question I have. I keep moving it to the right for positives. Why don't I move it left? We're going to answer that in just a couple minutes. You're going to see in cases where we do move it to the left. But let's look at 1, 2, 3, 4, 5, 6, 7. So I need to add zeros to these spots. And in this case,
to the office, please. Bren Gallagher.
And there we go. Alright, now in this case I have something just a little bit different here. I have 1.35 times 10 to the negative fourth. Well, in this case, when I have a negative exponent and I'm going to standard form, this tells me how many spots I need to move it to the left. Negative, that tells me, when I have a negative exponent, that tells me I'm going to have a decimal in front of the number. So it tells me here, okay, negative exponent, I need to move it 4 times. 1, 2, 3, 4. So I'm moving the decimal to in front of the number instead of after it. So then I come up with 0.000135. Again, I'm moving the decimal with negative exponent. I'm moving it to the front. Alright, let's look at this one. I want you to try this one. This is a practice. 1.33 times 10 to the negative fifth. So in this case, I want to move it again to the left. Negative tells me I need to go to the left 5 times. 1, 2, 3, 4, 5. Now place my decimal here. 1, 2, 3, 4 zeros. 1. So in this case, and if you notice, this is a really small number here. So, and that's the way scientific notation works. I know as we watched the video in class, you got to see a real kind of a picture of how small this can be, or how big some numbers can be, and how many zeros you can actually deal with. So go ahead and try this one on your own. In this case, I have 3.9. And another point I want to go ahead and make, if you notice, it's never 39 times 10, it's never 24 or 0.32 to the 10th. It's always a number that's between 1 and 10. So as I'm moving, as I move the decimal, and you'll see where that comes into play in just a few minutes. So I say, okay, 1, 2, 3, 4. 0.00039. Alright, on this one, we can take a minute and work these out, and we'll see if we match up and come up with the solutions. Alright, on this one, 9.2 times 10 to the 6th. Well, I'm going to go ahead and work it out right here. 9.2, that's a positive. Tells me I got to move that to the right. 1, 2, 3, 4, 5, 6. So that decimal is now at the end. Alright, the second one. When I have 6.7, I'm actually going to scoot that over because I'm going to be moving that decimal backwards there. So I have 6.7. And as I say, 1 negative exponent, 2, 3, 4. Again, that tells me how far I move the decimal. I go down to the third one. I have 3.6 times 10 to the negative second. Well, that negative exponent, again, tells me I have to move it to the left. It's going to be in front of the number 1, 2. 0.036. Alright, and the last one, I have 5.24. Well, in this case, I'm going to go 8 spots to the right. Positive exponent. 1, 2, 3, 4, 5, 6, 7, 8. And there you go. Here's my advice as you've worked through this. If you got at least 3 of the 4 right, then I'd feel free to go on. If you missed any more than 1 of the 4 here, I would definitely go back and review what we've done so far before we head on to the next section. Alright, so we look at the next section here, translating to scientific notation. Now again, this is where I was talking about specifically has to be between 1 and 10, and I want to make sure, for example here, I want to get it to scientific notation. This is the standard form. In order to do that, I'm going to have to move the decimal. Again, I know this is a really small number. I notice the decimal is in front of the number. That tells me I'm going to have a negative exponent. So I go 1, 2, 3, 4, 5, 6. Now here's where I was talking. I can't stop here at 0.3. I have to make the number between 1 and 10. And so I move it one more spot. So let me recount. 1, 2, 3, 4, 5, 6, 7. So I will have 3 times 10 to the negative 7th power. Alright, the next one, I want you to try this one on your own. Before I work it out, make sure you continue to pause the video at each problem and work it out for yourself, and then just compare with what I have. That way you will be able to tell whether you understand it or not. Alright, in this case I have, let's we've got to move it, and I know again it's decimal. In front of the number, negative exponent. 1, 2, 3, 4, 5. Can I stop here at 5.7? Well, is that between 1 and 10? It most certainly is. So I have to say 5.7 times 10. And I moved it 1, 2, 3, 4, 5 to the negative 5th power. Alright, again, this is very similar. I'm going to skip on over to this one. 6,980,000. Alright, I don't see the decimal in front, so now how am I going to write this one into scientific notation? So I'm going to have to start from the other side. I want you to go ahead and try this one, and you know it's not going to be a negative exponent, it's going to be a positive exponent. Same principle, just a little bit different look. Alright, so in this case, I know I'm going to start back here and just count the spots. 1, 2, 3, 4, 5. I can't stop there. 69 is definitely not between 1 and 10. And let's go to the 6th one. Okay, so also I'll say 6.98 times 10. I think it's the 6th one. 2, 3, 4, 5, 6 times 10 to the 6th power. Again, this is just a practice of a negative one again. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So I have 2.5 times 10 to the negative 8th power. Alright, take a minute and go ahead and work these out. Pause the video. Again, I want to make sure out of the 4, if you end up getting at least 3 of the 4 right, hey, I'd feel safe to go on. Maybe you want to go back and just kind of look at your problem. It could have been just a counting mistake, and that's all. But if you get any less than 3 right, I would definitely go back and rewatch the last section of this video. Alright, in this case, let's look at them here. 1, 2, 3, 4, 5. So I have 7 times 10 to the negative 5th. On the second one, okay, I have here it's positive. And we also notice that the decimal, there's no decimal in front, it's going to be after. That tells me it's going to be a positive exponent. 1, 2, 3, 4, 5, 6. I have 6.5 times 10 to the 6th power. The next one, again, no decimal in front. That's going to be positive, positive exponent. So 1, 2, 3, 4, 5, 6, 7, 8. I have 1 times 10 to the 8th power. Now the last one. Decimal in front, negative exponent. So I'm going to count it. 1, 2, 3, 4, 5, 6, 7, 8. I have 3 times 10 to the negative 8th power. Alright, as we get into the next section, this is the part, I know the other part as far as class today we covered up to that point. But now if I want to get into adding and subtracting, how do I add and subtract numbers written in scientific notation? Well, let's get started. And this is where, honestly, a lot of our rules that we've talked about before are going to come into play here. As I look, same base with the exponent, same base, I'm adding. In this case, still, no calculator really needed yet. So all I'm going to do here, I'm going to say, okay, I have my 3.1 plus 2.8. And I'm going to get 5.9. Well, then times 10. And remember the rule here. When I'm adding, same base, same exponent, just combine my like terms, times 10 to the 7th power. Just like that. Alright, so in this case, go ahead and try this one first. I have 3 times 10 to the 5th plus 6 times 10 to the 5th. Well, in this case, let's just take and add 3 in the 6. Gives me 9. But then I come back and I say, oh, 10 to the 5th, 10 to the 5th. Same base, same exponent. I'm adding. And I would have 9 times 10 to the 5th. No issues so far. Alright, on this one, same thing. We're still adding. You have 4.55 times 10 to the negative 6th plus 2.81 times 10 to the negative 6th. Go ahead and try this one on your own. In this case, well, 4.55 plus 2.81, you get 7.36. Again, same base, same exponent, times 10, negative 6th. And that's with adding. Again, it's just like what we've been working on. Same base, same exponent, adding. Alright. Now, we do have a little bit of a difference here. Instead of adding, we're going to be subtracting. Same rules apply. I have 2.7 minus 1.1. Now make sure you go ahead and pause this before I go over it, and try it on your own first, and then compare. Well, 2.7 minus 1.1, and you come up with 1.6 times 10, same base, same exponent, to the negative 5th power. Alright, let's go on here now. Alright, here we do have a little bit of something different. and I want to talk to you before we practice any more of these. Let's look at this one. All right, I'm going to look at 7 times 10 to the 8th minus 6 times 10 to the 6th. Now there's several different ways to do this, and I know it's taught several different ways. I'm just going to give you one way that's just easy for me, and then you may find other ways, and that's perfectly fine as long as it's mathematically correct. I won't complain. So let's look at it. I have times 10 to the 8th times 10 to the 6th. Cannot combine that, especially when I'm adding and subtracting. I can do this. Between the 6 and the 8, there are 2 spots. Now you got to remember, when you're dealing with times 10, well, it's like I'm saying 10 to the 2nd power. So that would equal 100. Well, in this case, this is the one I'm changing. So I can say 6 divided by 100 because it's 2 spots. Again, I just think of it as in tens. 10 squared, 100. So then I'm going to go 6 divided by 100 is going to give me 0.06. So what that has done is changed the second one. Say 0.06 times 10 to the 8th. Again, let me say that one more time. I want to make sure you get this correct and you understand. And again, if you have questions, you can either post it to our today's meet, and I'll get to it tomorrow. As when I open it up, it'll be there. You can tweet it, and I will be able to answer it from there. It's perfectly fine either way. Again, here we go. I said this. I said, okay, there's a difference. It can't combine, right? Difference of 2 here. So I look at it as 10 squared. That's 100. So I'm going to say, okay, 6 divided by 100, 0.06 times 10 to the 8th. Did not change the first one, so I'm still saying 7 times 10 to the 8th minus this. Now you have the same exponent. Now you can actually combine it. And so now I can say 7 minus 0.06 equals 6.94 times 10 to the 8th power. Again, if this is confusing, please do ask me. And the only time really you have to worry about this is when they're have separate exponents. And I'm going to tell you as we go through, I can show you how to do this on a calculator to check it. But right now, I really want you to focus on the process, on being able to work these out without using the calculator as much. Alright, as we go through, again here's some checkpoints. You can work through these, and let's see how we do, and then we will compare in just a minute. Alright, as I go through, what I want to do is I'm going to write down the answer to each one of these, and then that way you can compare and see what you come up with. Alright, here we go. On the first one, 4.3 times 10 to the 12th plus 1.8 times 10 to the 12th, you should have come up with 6.1 times 10 to the 12th. If you did not, definitely go back and review about adding 4.3 plus 1.8, same base, same power. Alright, on this next one, I know same base, same power, so I know it's going to be something times 10 to the 8th. Well, 9.21 minus 4.91, come up with 4.3 times 10 to the 8th power. Alright, the next one. We've got a little bit different here. Here, I know it's adding. It's still going to be the same thing where they're not the same. I have to raise this one. So again, there's only 1 power difference. So instead of doing 100, we'll do just 10 in this case. So for example, from 9 to 10, there's just 1, right? So that means, okay, it's just 10 to the first power that I need to look at. So I take 2.7, and I'm going to divide it by 10. And when I do that, I'm going to get 0.27. So essentially this one changes to 0.27, and then that tells me that's to the 10th power. So now in that case, I can just simply say, okay, 9.1 plus 0.27 is going to equal 9.37, and it will be times 10 to the 10th power. Again, I just had to raise this up one time to 1 power by dividing 2.7 by 10. Again, if it had been by 2, we would have done by 2 power, or it'd be 10 squared, but it's not, so it's just 1, so you only had to do it by 10. Alright, on the fourth one, when I get 8.3 times 10 to the negative fourth minus 7.5 times 10 to the negative fifth, when you do that, and again you're going to have to raise it 1 power, you should come up with 7.55 times 10 to the negative fourth. So, and I think I am going to go back and I'm going to show you one of the ways that you can do this on a calculator. Again, this is not to say, oh, rely on a calculator by any means. I really want you to be able to go back and check your work. I want you to be able to check what we do, because through this in class, you're going to have to show your work anyway. So let's take a look at how this would look on a calculator. For example, okay, I'm going to go ahead and put my calculator right here. I'm going to clear it, and I'm going to say I'm going to look at that last one, even with the different exponents. One way you can check yourself, for example, I'm going to put parentheses. Okay, I can say 8.3, and the way I'm going to get times 10 on this calculator, you're going to push second, and then there's the comma button right here, and it's also EE. That E just simply means times 10 to the, and then I fill in negative 4 for the negative fourth power. And I can say minus parentheses 7.5, again second E negative fifth. And when I hit enter, it's going to give me 7.55 times 10 to the negative fourth. Now another good thing about the calculator in some cases in this sense is it don't necessarily give it to you in scientific notation. It will give it to you in standard form, and you have to put it back in scientific notation. So really it does no good to really just rely on the calculator. But I did want to show you that because it is a good way to check, and you can do this for any method we use to be able to check it. And again, don't get too comfortable, because in class you will have to show me all of your work. So let's go back to here, and let's talk about how do I multiply and divide numbers written in scientific notation. And this will be the last section of this session. So if I look at this, I know, okay, I've got to multiply. So now, again, I got to think, what's the rule when I multiply? What do I do to the exponents? Some things change there. Well, in this case, when I multiply, I need to add my exponents. So here, again, 3.5, I can go ahead and say times 2.1. And when I do that, I'm going to get 7.35 we're going to say 7.35 times 10, and then I'm just going to add my exponents, negative 4 plus 9, and I would get a positive 5. Alright, as I go through this, now you're going to notice a little bit of a change because I've had to change my battery diode on my portable. So now, as I go through here now, I'm actually at the Promethean board. But if I say 2 times 10 to the 7th times 3 times 10 squared. Go ahead, I want you to work this first. Remember your rules about exponents, remember your rules about the bases. So in this case, if I have 2 times 3, 6, then my rule about the exponents, 7 plus the 2, so I have 6 times 10 to the 9th power. Again, if you want to use the calculator to check it, again, you got to put it, make sure you put everything in parentheses. It's 2 second e 7, then times 3, or in parentheses, second e 2, and then you can get to, again, it may give it to you in standard form, which is going to make you put it back in scientific notation, which is great too, but do not rely on that calculator. Alright, go ahead and do this one. I have 1.3 times 10 to the 5th times 4.2 times 10 to the 13th. I'm going to go ahead and scoot this problem over. There we go. And when I do this now, again, you work it first. And you should come up with 5.46 times 10 to the 18th power. Again, multiply, and then I'm going to add these. So when I multiply, I add my exponents. Okay, go ahead and try this one. I have 4.7 times 10 to the negative 6th times 1.8 times 10 to the negative 5th. Okay, in this case, I should give it 8.46 times 10 to the negative 11th. Alright, the last section is what are we going to do now to be able to divide? If you remember, again, it goes back to our exponent rules. Well, when you divide by the same base, you just do what to the exponents? Well, you're going to subtract. Again, same base here. Again, I'm going to divide these numbers. So in this case, I'm going to say 8.4 divided by 1.4. And I should come up with 6. All I did was divide. Okay, from here out, times 10, because that's my base. Then I subtract my exponents. 14 minus 12. So I'm going to come up with 6 times 10 squared. Alright, let's look at this one. What I want you to do, go ahead, pause the video, work through this problem, and see what you come up with, and we'll compare it. Alright, in this case, you say 2.8 divided by 1.4, and I'm going to come up with 2 times 10, they're the same base, 15 minus 7, so I'm going to come up with 2 times 10 to the 8th power. Alright, another one. Now this one, I'm going to go ahead and tell you, be careful with this one. Be careful. The process hasn't changed, but be careful with it. Work it out, and then I'll work through it in just a minute. Alright, let's look at it now. Again, here, 7.7 divided by 2.2, 3.5. Same here, times 10. Now, if you're not careful, you'll say 11 minus 6. And you get 5. But look carefully at what it says. The rule is you subtract the exponents. 11 minus negative 6. So in this case, I'm saying negative, negative, so it's actually going to be 11 plus 6, and you will have 17. Again, the reason I did that, 11 minus negative 6. And so it turned it positive, so 11 plus 6 is 17. 3.5 times 10 to the 17th power. So you just have to make sure. And again, if you choose to use a calculator on this one, you have to make sure you use parentheses. And I will go ahead and show you what I mean by that. Just so, I don't want to get you messed up, but again, you can check it. It's a great way to check it. And make sure you check your work. So if I want to do, say, and this may not even be the same problem exactly, I'm just going to kind of, if I want to do that, I got to make sure I put it in parentheses, 7.7 second E4, and then say divided by parentheses, 2.2 second E, we'll say negative 2. Again, see how it gave it to me in standard format, and then it's still up to me to be able to put it back into scientific notation. But again, don't rely just on the calculator. And again, I use it to check my work. It's a great way to check, but don't rely on it, because more times than not, it can actually mess you up. Alright, here's another example. 7.75 times 10 to the 16th divided by 3.1 times 10 to the 4th. So in this case, when you divide, I'm just giving you time to work it out before I do. I'm going to get 2.5 times 10, again, subtract, squared. 7.75 divided by 3.1, you get 2.5, 16 minus 4, and you will get to 2.5 times 10 squared. So here's where we're actually going to be doing this in class. We're going to be doing some tasks. It is important to know the process of how to do it, because as we do, we're going to be applying it to the real world and real life situations in the next few days. So keep this in mind. How can I use scientific notation in the real world? One thing that you will need to make sure you definitely tell me before class that I know that you've watched this, and always be ready for a quiz over the video. But you will need to write down, today I will do my best and be successful. And bring that into me, signed by someone at your house that you have actually watched the entire video. Again, it's today I will do my best and be successful.